So thank you for coming. Slightly more people than I expected on a talk which is really supposed to be very simple. Functional interfaces. What is a functional interface? It's got a single method. And that's about it. So I gave this talk in Athens, and they gave me 35 minutes. So I've got a bit more time. So why don't we start at the front and just stand up, give us your name, who you work for, and we'll just go through the room like that. Try and use up some of our time here. Anyway, so I'm Heinz. I'm a Java consultant, teacher, programmer. I'm from South Africa and I live on Crete. And people ask me, why on earth do you live on Crete? So I just show them a picture of my son jumping into the sea. I created the Java Specialists newsletter quite a while ago. And because of that, I became a Java champion also quite a while ago. And I'm the unfounder of the hottest unconference called Crete, which I can't invite you to because it's full for the next couple of decades. Unfortunately, we've got a limited space, so it's very difficult. Anyway, let's talk about functional interfaces. And let's see what is a functional interface. Now, it all starts off quite simple. We look at something like Greet concurrent. And Greet concurrent is, inside we construct a new thread, and we give it an anonymous inner class. So this is the old syntax. There's nothing new about this. This has been with us since Java 1.1. We make a new runnable, and the runnable inside calls the method say hello. And we then say public void run, hello, and we know the syntax. We know it's really ugly. And in Java 8, we've got the simplified syntax. We can simply say new thread, and then round brackets, because parameters, so it's not round brackets, and then minus greater than, say hello, dot start. So it's, of course, makes it to look much nicer. Now, the question is, what can be a Lambda? And when I first started looking at Java 8, I was a little bit confused by this, to be honest, because what is a Lambda? Well, first of all, it's an interface. So the functional interface that you use has to be an interface that has exactly one abstract method, right? And now it starts to get a little bit tricky because methods that you inherit from object don't count. Well, some of them count and some of them don't count. So what we're going to do is we're going to look at some example interfaces, and you will have to vote by a show of hands whether it's a functional interface or not. All right. The first one is hopefully going to be relatively easy. Who says this is a functional interface? All right, so that's a pretty good crowd. Who says it's not a functional interface? Okay, a couple of jokers around there. No, it's okay. So we know this one is. And in fact, there's this annotation we have in Java 8 called @functional interface, which checks that we are abiding by the contract. So it's an interface with exactly one abstract method. It has to be public anyway. You don't have to say public abstract. You can simply say void run, and that's automatically public and abstract. So because it's a functional interface, we can now use it wherever you see Lambda. So if you see the threadpool.submit, round brackets, minus greater than, or arrow, say hello. All right, now, what about this one? ActionListener. Who says this is definitely a functional interface? Okay, slightly less hands, but still quite a few. Who says it might be a functional interface? Okay, a few more hands. Who says it's not a functional interface? Okay, nobody's brave enough to stand up against the crowd, right? All right, so the answer is not so simple. We can't just say yes or no because we can't see it from this class by itself, or what's interface by itself, because we first have to look at event listener. You see, ActionListener extends event listener. So without looking at event listener, we actually can't say for sure whether or not this is a functional interface. Right? So the second group was probably the most correct, although the first one is also correct, but the second one is even more correct, if that makes any sense. No, it doesn't make sense, I know. Sorry, I don't make much sense at the moment. So event listener doesn't have any methods. So therefore, it is not a functional interface, but the sub-interface called ActionListener has exactly one public abstract, it has to be public abstract, method, and it's an interface, so therefore it is a function interface. Okay, now before I carry on, I must just warn you that I'm going to use examples from Swing, right? I don't really use Swing that much in my productive work. It's just that it's a good example to use. All right, what about this one? So now I've got one public abstract method, but I haven't said it's public and abstract. It's automatically public and abstract because it's inside an interface. Who says this is a function interface with one method, right? So that's quite a good show of hands. Okay, there's a couple of people are sure. Okay, who says it's not? Okay, so some say slightly more say it's not, and actually it is not. Very good. And the reason it's not is that the method toString is defined on object. So if you put a toString method inside your interface and say you have to implement this, then you don't actually have to implement it at all because it's already implemented inside object.toString. There's one example where they do this in Java called the comparator. Inside the comparator, there are two methods defined: compare and equals. But you don't have to actually implement equals because that's already defined inside object. So a comparator is an example of a functional interface, even though it's got supposedly two methods defined inside. Now, if you look at object, these are the methods which are defined inside object. And so the question is, which ones can we override and which can be ignored in the count for the functional interface method count? And first of all, if a method is final, then you can't override it. So you can't override getClass, you can't override notify all, wait, the three different wait methods. None of those can be overridden, which is one of the many reasons why when they made condition there to have different names for these, await and signal all. So we can cross those out. We don't need to worry about the final methods. Then we've got public non-final methods for function interfaces. And these non-final methods, these do not count as part of our count to decide whether something is a function interface or not. And then I've got methods which are protected. And if the methods, in this case, are inside our method, inside our class, then, of course, the question, is it a function interface or not? In that case, it would be possibly, if that's the only method inside your interface. So it's not always so obvious and easy. Right, now here we've got another two interfaces. We've got foo1 and bar1, right? Foo1 contains an equals method, right, and bar1 contains a compare method. Bar1 extends foo1. So let's see again. Who says that foo1 is a functional interface? Okay, a couple of people scratch their nose and quickly put it down again. Very good. Who says it is not a function interface? Okay, very good. This is going to help you when you start using it, because then you'll figure out why it's complaining, why the compiler is complaining about certain types of classes. And what about bar1? Who says bar1 is a function interface? Okay, who says it's not? Who says it is? Who says it's not? Who says it is? Okay. Very good. Just making sure. This is a checksum, you know. So the foo1 is not a function interface because the equals method is part of object already, and it's a public method. So therefore, we can ignore that. It's not part of our count. Whereas with bar1, we've got an additional method called compare, which takes some parameters. And so there we are sure that this is, in fact, a function interface. You've got another example. I mentioned this already. Comparator. Now it should start becoming a bit more clear. Comparator does have two public abstract methods. And again, just remember, even if it's not mentioned that it's public and abstract, it automatically is public and abstract. So now I've got an equals method and a compare method. And we already said that equals is it's an implicit member. It's in every single method, in every single class. That, of course, means that the equals method must take an object as a parameter. If you have an equals method which takes anything else as a parameter, then that wouldn't be that would be an additional method that wouldn't be part of the standard object signature. And then we've got the compare method, which is our only abstract method inside that interface. The other one doesn't count. Okay, what about this one? I've got two methods, int m and object clone. Who says this is a function interface? Okay, so it's about 10 hands. And who says it's not a function interface? Okay, so this time democracy wins. And actually it loses, because the clone method is not public inside object. So by having an int m, which is public, and by changing the visibility of the clone method to be public, we've basically made two methods, two public methods, inside the clonable foo, and therefore this is in fact a function interface. It's not. It's not a function interface, right? I've crossed it out. Right. All right, now this one, the next one is really, really difficult, so you've got to concentrate really hard, okay? Are you ready for this next one? Good. What about this one? This is a MouseListener. Who says this is a function interface? Really? Nobody? You're just trolling there. Okay, who says it's not a function interface? Right? Hopefully most hands go up. Very good. So this is not a function interface because we've got 5 abstract methods. Right? 5 different ones. So you can never use this in the example that you would expect it to use. Like, let's add a MouseListener to a button. Right? For that, you can't use lambdas. And I got really confused when I saw this for the first time. Now, I want to look at some of the fundamental functional interface that we have available for use. There are sort of 5 or 6 very distinct ones, and then there are lots of variations of that. For example, you have like an int predicate, or lots of different types: int supplier, long supplier, double supplier. I can't remember what they all are, but for different primitive types, you also have different types of methods, different types of functional interfaces. So Java 8 gives us certain. Now, when I see words like this, I get confused as well. I get confused quite easily, as you can see. And I wonder, in which case would you use what? And are there any good use cases for some of these new constructs? So we've got supplier, we've got consumer, predicate. And you might think this consumer, that's for producer consumer. Well, in this case, it's a supply and consumer type of system. Predicate, function, unary, binary operators. How do you use these? So the way that you would use supplier, for example, is if you want to supply an object. In other words, if you want to do, in a way, lazy initialization. So I'm not going to construct the object up front. What I'm going to do is I'm going to provide a way in which the object can be constructed later on. Okay, so you might want to delay object creation until a later time. Or you might want to provide a mechanism with which somebody else can construct an object also at a later time. So I took this example from the Java util logging framework. In my one course, I talk about logging, and I say that everybody likes to write the logging framework, so everybody always has a better idea of how to do this stuff. Logging is supposed to be like a no-cost event, and unfortunately, it often costs a lot. So what we've done here is the first foo says logger.find, and in there I say milliseconds since 1970, and then plus system.currentTime millis. So that's the one side. And then the other side, this is now the newer version, I pass in a supplier of strings. So the log method, all the log methods in Java 8 also accept suppliers of strings. So instead of passing in a string, I pass in a supplier of string. And inside the find method, if you look at inside the Java util logging class, you'll see it will say log level find, and then message supplier. And then internally, they'll say, is the level enabled? If yes, then use it, then construct the object, otherwise don't construct the object. Okay, now this is an extreme example. So I've taken like probably the worst possible example to show you, because when you call system.currentTime millis, it's not going to be done in like 1 nanosecond. It's going to take a while to call this. It's actually quite expensive. And on top of that, I'm constructing a string every single time. So let's have a look at what happens when we do that. Let me just go back to this over here. So let's say that I want to have these two different mechanisms of logging. The one is foo, where I am going to call the logger with the new mechanism. Now remember that I'm not actually going to log anything. It's going to be blanked out, so it shouldn't cost anything, or should cost very little as well. So fine, and then milliseconds since 1970 plus system.currentTimeMillis. Let's make this a bit smaller. And we'll create a field for this, make it static, the usual story, final logger. The reason I'm typing so poorly is because my hands are actually ice blocks. If you're sitting in front, you know what I'm talking about. Equals logger.getLogger with the name, which will be loggingcrazy.class.getName. And now the traditional way of logging, let me just, would be to simply create a string and pass it along, right? So this is the old way. Of course, you have alternatives. For example, what you could do is you could, instead of creating the string, you could have, for example, a format string, and then a comma-separated list of values that you pass through. But in both cases, it actually doesn't really help you, because if you do that, you're still going to do the system current time millis eagerly before you actually go into the method. So in both cases, you're going to have this massive cost of the system current time millis as part of your logging framework. At least if you do that, you're going to have a very nice opportunity for optimization later on. I always tell my friends, always the first version of product always ship with -xint enabled. Okay, so we now call this 1 million times. We're going to call foo and bar. So we're going to make a logging crazy here. LC equals new logging crazy. Time equals system.currentTimeMillis. And then we're going to call lc.foo 1 million times. Now, as I said, this is an extreme example, but if you apply this throughout your code base, it actually can make quite a big difference. And I'll print out the value of the time. So this is for the foo, which is the old way. And now we're going to do the bar, which is the new way. And we'll see what the difference is in runtime. If you want to do a proper benchmark, then you can take the Java micro benchmarking harness. This is not a proper benchmark. I'm not claiming it to be. You can see here that this looks like it's a bit faster, but we actually haven't run it long enough to really spot the difference. If you put this into, so let's increase this, make it up to over here. And then in there we increase the count a bit, then we might be able to see a bigger difference between the two runs. Is something broken? No, it's not broken. It's just very slow. As I said, this is a really extreme example. Please don't log system current time millis like that. Not a good idea. It's an extreme example, but it's illustrating the point that by having a supplier, we can quite nicely create this lazy initialization of values. Okay. The second type, which is quite common, is a consumer. So suppliers objects, can create them on demand. Then we've got a consumer. And the consumer would be used for accepting end information. So for example, if I've got a collection of names, I could print them all uppercased by passing in a consumer to the for each method. So one of the nice things they did in Java 8, one of the many nice things, was they have this thing called a default method, which allowed them to modify existing interfaces like collection. Prior to default methods, it wasn't really possible to change an existing interface. As Brian mentioned this morning, But of course, there's also other ways we can abuse default methods, which I'll show you a little bit in a few minutes. But here what we can see is I've got names.forEach, new consumer, and then public void except string. Now, again, I get quite confused with these lambdas. So what I do is when I want to make a new lambda, often what I'll do is I'll construct the anonymous inner class first, because that is the syntax I know very well. And then I'll use auto fixing with IntelliJ to convert it into lambda for me. It really, initially, it helps a lot to get the syntax right. Just for the first bit. Once you know it, then of course you can just code it. But initially, just to understand how this works, to me it was a great help to do it that way. Just code it and then autofix, Alt-Enter, convert to Lambda, and it's now looks very neat and tidy. So this is what it looks like, the Lambda. And because what we could also do is instead of having a for each directly on the elements, we could first map the elements to uppercase, and then for each one print them out. So in other words, over here, what we're doing is we're printing every element as uppercase, but we could first uppercase each element and then print them out. And so we've got another nice syntax we have in Java 8, which is the method references. So what I'm saying is I'm saying names.stream and then .map. So the function I'm going to apply to each element is the to uppercase function, which is inside the string class. And for this particular consumer, that's not a computer, that's a function. That's going to convert a string to a string. But you can also convert a string to something else if you want. It doesn't have to remain a string. You could convert it to some other type of class. And then we have .forEach, where we then would call system.out.println. So this would do the same thing as the previous mechanism. Have the same output. Another one is a predicate. And again, I'm using the long form first, and then I reduce that with autocorrect down to the nice Lambda version. And what I'm saying here is I've got some array list, and I then say names.remove if, and I pass in a predicate that allows me to remove certain types of elements. So names.remove if, new predicate, and then the test that I am going to apply is that s.contains I should be true. And actually, I'm almost certain that this is not going to work, this code. Because arrays.asList, you can't change the length as far as I know. So we'd have to just wrap it with another array list just to make sure that this works. So if you try this out in your code, don't be surprised if you get an exception. You'd have to maybe wrap it with another collection. Okay, I just wanted to keep it as short as possible. Now, names.remove if would do the following. Here I'm passing in the Lambda again, and again you see it's so much nicer and neater to work with, just s and then arrow s.contains. Now you can also say brackets s, the round brackets s, but the brackets are unnecessary parentheses. You don't need to have them there. You can also say bracket string s, but again it's redundant. You don't need to say that. You can if you want to, but to me that doesn't really make it more clear in most cases. The function maps from one type to another type. So if, for example, I want to return the length of each element of a list. So what I'm doing is I'm saying names.stream.map, and then I'm passing in a function. And again, I'm using the long form first because it makes it so much easier to go from the long form later on to the later one and actually know what's going on. Well, actually, it's not exactly this. The Lambda is not an inner class. You mustn't get confused with that. It's not the same. The Lambda does work differently. But just from an understanding point of view, it's easier to understand it this way. So names.stream.map, I'm passing in a function which takes a string and converts it to an integer. This is my function I want to have. Now you can see there's a lot of code there. It's public integer apply, taking a string, and I return, if s is null, I return 0, otherwise I return the length of s. And of course, you could write it much simpler by saying names.stream.map and then to say s arrow s equals null, give back 0, otherwise give back s.length. These were all pretty easy to understand. Now I'll get to some which are a little bit more complicated to find good use cases for. For example, the unary operator, operating on yourself. So here I've got an example, replace all. If I want to replace all the elements inside a list, this has to be a list. Replace all is not defined on collection, it has to be on a list, because it's going to replace it by index. And so you can't, for example, apply this replace all method to a tree, because by changing the object, it might appear at a different place in the tree. So this can only be done for lists. And so I say names.replace, and again I pass my unary operator, and this returns s.to uppercase. Now, an easier way of writing this is to say names.replace s arrow s.to uppercase. So this function, this new functional interface that we've got called unary operator, is applied to every element inside the list, and each element is then replaced by what was returned by that particular method. So this way, I'm converting everything to uppercase. But whenever you've got a very, very simple method call like this, you can usually replace it with the method reference. So again, we could say string, : to uppercase, and that method reference would then be used instead of a lambda. Well, it is a lambda, but it's just a short form, instead of saying s arrow s.to uppercase. All right, so all of this helped me a lot to understand how these things work. Okay, now we get to something slightly different, because so I write this newsletter called the Java Specialists newsletter, which is for people who like doing things which are a bit more advanced than just the basics, right? And I got annoyed a little bit because I got so confused initially by trying to have a MouseListener for a button, for example, just to say, okay, so ActionListener is a good example, and that's in fact what the state of the Lambda document starts with that, and says, if you want an ActionListener, it's a Lambda. So I immediately thought of that as being a Lambda. And so, unfortunately, most of the AWT listeners are not function interfaces, because they have multiple methods inside. I think we all know now exactly what a function interface is. So most of them are not, because most of them have multiple methods inside. And what we would do in the past, those of you who are old enough to remember this, we would, if you're working with Swing, you would say like salary increaser dot add focus listener. Let me show you this little code. I think you'll like it. Now, what I've done is all the code that I'm going to show you now, I've actually got available on a GitHub repository. So if you're interested to try it out, you're welcome to do that. This is my salary increaser. This is how it works when I try and get my salary increased. I just press the button and I can increase the salary. Oh, okay. That's not how it normally works. Normally it works like this. Okay. Come on. Come. For some reason, I'm not quite sure why. Sometimes it doesn't pick up the event properly. And it does let me catch it, but normally it doesn't. And I've even done it so when you tab onto it, and you press, okay, I can't do it, let's try it once more. If you tab onto it, if you're like in focus, now you should be able to press space, and that should activate it. It says, not quite. It also doesn't accept it. So these are the events that are going on. Now, you've got mouse events, you've got mouse entered event, mouse exited event. You've got, actually mouse exited might not be so important, but mouse entered is important. You've got clicked, you've got spacebar pressed and so on, and those are all very important in order to try and get this person to increase his salary. Okay? Now, the way that we would code this in the past is with adapters. So we've got here the add focus listener passing in a focus adapter. And when I couldn't get it working, I did what everybody else does. I went to Google. I said, Google, please tell me, let me Google that for you. How can you use, focus listeners as function interfaces? And there were a whole bunch of articles written which had some old ideas of how it should work, which didn't work, right? So I really set out to try and figure out a way to solve this, and probably also solve other problems at the same time. All right, so this is what we had pre-Lambda. Every component we would say add different types of listeners, focus listeners, key listeners, mouse listeners, and so on. But what I really wanted was something like this, to be able to say, if it's a focus gained event, then do the following. If it's a key pressed event, then do something else. If it's a key released event, I want something else to happen. A key clicked event, or so there's one, I think it's only pressed and released, then do something else. So I wanted to have different things. So if, for example, if you say key pressed, I consume the event and I don't pass it on to whoever else is listening to it. So this is what I wanted to get to. But how do you get there? Okay, so how do we get there? You see, focus listener has got two methods. So we know this is not a functional interface. So it's not simple that we can simply say, bracket or use a method reference. That doesn't work. And in the first example, we actually used a focus adapter. And originally the idea was that objects are very expensive to construct. So they tried to reduce object construction in the early versions of Java, Java 1.1. And so they had a mouse adapter or a focus adapter or key adapter, so they could only override the methods that they wanted. And they called it an adapter. Now, it always causes confusion because people think that's the adapter pattern. It's not. It's not the adapter pattern. So what I did was I produced this thing called a Mixin. So what I do is I take the one abstract method that I've got available, okay, called add focus listener. I know that this add focus listener is going to be available on every component, for example, because it's, for example, defined on the J component. So I know that if for example, I take a subclass of J component, and this J component implements my focus event producer Mixin, I don't have to do anything else in order to get this to compile, because that method is already there. So I'm simply writing there what's there already. And then what I do is for each of the different events, I add another method. So for example, I would have add focus gained listener. This would pass in a consumer for a focus event. Remember consumer we had with the for each, for example. So the consumer would be applied to any element that's inside there. Right, so the consumer is passed in, and then the add focus listener would pass in a focus adapter, and this adapter would call focus gained for that focus event. And the consumer has one method called accept, and this method would be called whenever somebody calls whenever somebody loses or gains focus there. So by adding this method, now default methods were not designed to do this. Default methods were designed to help us evolve interfaces. So if you want to have a for each method inside a collection, you can do that without breaking existing contracts. It's very important to have that. This wasn't really the design initially. And for add focus loss listener, it's very similar. So what we do is we have now an add focus listener which calls the method which is going to be there anyway, and I'm passing in a focus adapter which calls the focus lost method, and this then calls the accept method. So what we've done is we've defined an interface with default methods, and I've added a method for every type of event that could happen on a focus listener. Now again, please don't get stuck on the swing. Swing is really old school. I know some people still use it, but it's old school. Don't get stuck on that. Think of it a bit more abstractly, because I actually found a very good use case for this shortly after I thought of it, which had nothing to do with swing. So we add focus gained listener and focus lost listener. And we also have the abstract method add focus listener interface. Now, the one part which is a little bit confusing is if we go to this previous interface, this interface is a functional interface. But that's, in this case, completely irrelevant. We won't use it as a functional interface. That's just by the way. Nobody cares about that. What is important is that we're using this one abstract method in order to add focus gained listeners and focus lost listeners. Now let's see how we can mix this into a class like a JButton. So this is where the magic starts now. So the JButton already contains a method called addFocusListener, as well as addKeyListener, as well as addMouseListener, and for all the different ones I've got the add methods there ready. So all we do is we subclass the JButton, and we make it implement this Mixin interface. We don't have to do any other work. We simply make a subclass and do that. So it'll be something like public class JButton Lambda, extends JButton, implements focus event producer Mixin, for example, or whatever you call the Mixin. Now, we can also, of course, have constructors in order to have the same constructors as the JButton. And with our new JButton Lambda, we can now say salary increaser.addFocusGainedListener and use this lovely new Lambda syntax, arrow system out print line almost there. So we can use it in order to produce this amazing new code. So the JButton Lambda over here, this is now the full class, well, almost a full class. I'll show you the full class in a moment. But it implements this focus event producer Mixin. And inside there, we've got five different constructors which simply mirror the superclass constructor. But we don't actually have to do anything else. That's all. And we've now got a new type of button which has all this functionality mixed in. And I can do the same thing to a J checkbox. I can say implements focus event producer Mixin, and now I've got a checkbox which has focus functionality. Now, if you look at the hierarchy that you find inside AWT and Swing, the way it works is that the component has a whole bunch of methods. Now, I haven't put all the listener methods in here, and I hope that my text on this slide is not going to get me blocked by some firewalls. I've already been blocked by some companies because of my domain name, Java Specialists. You'll have to figure that one out. Okay, so a component has addFocusListener and addMouseListener, and but also other ones. And then the container is a subclass of component, which has addContainerListener and again some others. And then you've got JComponent, which is again a subclass of container, which has addAncestorListener and again some other ones. And then you've got the abstract button, which has addItemListener and I think some one or two others. And then lastly, you've got the JButton, which is a subclass of abstract button. So this is sort of the hierarchy that you have from the top, the component, all the way container, down to JComponent, down to abstract button, down to JButton. So what we can do is we can define a JComponent Mixin type that will give us access to all the XXL listeners in that Mixin and the classes above. So this is what my JComponent looks like. And then it's quite long now. Basically, this extends ancestor, component, container, focus, hierarchy, input, key, mouse motion, event, producer, Mixins, right? All of those. This is all from the superclasses. No, it's not. In fact, that's from JComponent, not the superclasses. So with any JComponent, you can have a mouse event, or a key event, or a focus event. And then what I also did, now this was necessary, I'll explain why in a moment, I also added all the other add methods which actually take function interfaces. For example, the add mouse wheel listener is a single event, so it's one method. So therefore that is already a function interface. So there's no need to have another producer Mixin for that. All right, now I needed to have those additional methods so that I have a common interface for all types of the same. So for example, if I want to have something which allows me to add listeners to types of buttons, I would say abstract button event producer Mixin, which I'm going to use for buttons, and this has the action event, the item listener, and the change listener. These are all different types of functional interfaces. They're already functional interfaces. But I need to have it so that I can have a common superclass for each of the different types of buttons. So here's my JButton Lambda. Public class JButton Lambda extends JButton, implements JComponent event producer Mixin, and the abstract button event producer Mixin, and all the constructors that he had before. And now I've got a little component that can react in a very nice way to all of the different events that happen. So let me show you my extremely ugly GUI. So if you ever wondered why Swing died or is dead, just have a look at this. Now this, of course, is IntelliJ. It's complaining that there's a bug, but it's actually not. It's just IntelliJ being silly. So let's run it. And you'll see now that we've got this incredibly looking GUI. This is actually the nicer version. AWT was worse than this. And you can see that as I move into the components, events happen at the bottom. So we've got a JLabel Lambda at the bottom, mouse entered, mouse exited. If I click it, there'll be mouse clicked, pressed, released, clicked, right? And for each of the different events, things can happen, item events can happen, action, if I click a button, it's an action event. And so I can have all of these events attached to the components. Are you happy? Yes, I'm happy. Options. Okay, so you have different things you can do. If I type something, hello, every time I press a button, it reacts, right? As I said, don't get stuck on the swing. The swing part is irrelevant. This is just an example, and this has other applications beyond swing, far beyond swing. This is what the code looks like. So I've got a JLabel Lambda. Now, of course, if you're Greek, you're probably going to want to change that to Lambda. Okay, just to really play with your colleagues. But you can see over here, I've got this sort of nicer syntax of E arrow rather than having to make have this adapter class inside. Okay, okay, now that's not the only way you can do it. There are also other approaches that one can use. For example, when I showed this to Brian a while ago, and he said, there's another way, which he showed me this one, is to have basically facades for each of the different types of listeners. So instead of exchanging button and extending J button with a mixin, you can also have like a facade for listeners, or for focus listeners, or for mouse listeners. So what you would do is you would say something like for focus gained listener, taking a consumer as a parameter, and this again would return a focus adapter, which would call the accept method when focus is gained. And then another one, which is a focus loss listener, which calls the focus lost method if you lose the focus. So in both cases, you're just wrapping an existing system with something else. So the way this would look is as follows. We've got add focus listener. We're taking as a parameter now this focus listeners.for focus gain listener, and there of course you could make it slightly more pretty by using static imports on the focus listeners facade, and then as a parameter I'm passing in this lambda e almost there, and the same thing I would do for the add key listener. I'd have key listeners.for key pressed listener, and so on. Now this, if there was a really big requirement to do this in Swing, I'm sure one could add this to the existing key listener classes, but or the key listener classes. But it's just as easy to have it externally done. So the way that the code would look now is as follows. So if you look at the add listeners method, this would be with a facade, would look like this. So you have one extra method call, but as a bonus, you don't have to subclass each one of your components in order to get that. The subclassing is not a big deal because all you have to do is implement the interface, and you've got all this mix-in functionality put into there for you. Okay. So I'll put in a bit of bonus material if we have time, which we do have, so that's good. We also have time for questions, which we'll take in a moment. Just, people often think that the lambdas are anonymous inner classes, and people have always said they're not, and they're not. They're not anonymous inner classes. They do work quite a bit differently internally. The core stack does have some differences. Now, if I, for example, have an anonymous inner class like this one over here, I've got runnable equals new runnable, and I say public void run Inside I call the method showStack. Now showStack is defined above that, and showStack simply says thread.dump stack. Now the dump stack method is not very smart. It simply constructs an exception that says .print stack trace. It really is not, it doesn't do any magic. It just prints a stack trace. And if you run it, what happens is that the stack trace is going to be shown, and you're going to see that there's this synthetic method that gets added to the stack trace, or to the class actually. So the output of the run, you'll see the exception stack trace, and then you'll see over here in the line 4, you see access $000. Now the reason they put that in was because when they introduced inner classes in Java 1.1, they didn't want to change the way the class structure works too much. So basically, in order to make a private method public or publicly accessible, they add these little methods in there. And so the static method that you see internally inside the method called stack class is called static void. Okay, so it's a package private class, method, sorry. Method call stack dot access $000 with method call stack. And so with Lambdas, it's a little bit different. With Lambdas, you've got more direct access to the outer class. Also, for example, if inside the Lambda you say get class, you're going to get back the outer class, the actual class in which you've defined it. If you do that inside a runnable, you get back instead you get back the anonymous inner class. And so it's much easier to use the Lambdas than the anonymous inner classes. And also it looks nicer. But you still have a synthetic method, synthetic Lambda method, except this time it's just a private method. It's not a static method. And this is called internally. They sort of bypass it slightly. Some special bytecode gets written. So in conclusion, I've got all the details inside my GitHub repository there. If you're interested, now just remember when you leave, you have to vote the green one if you like it, and if you don't like it, you also have to vote the green one. Okay, I'm just joking. Don't vote anything. The Lambdas, static default methods have been around since March 2014, but as people start to use it more and more, we're going to find out what the better idioms are. Now, I remember this morning when Brian put up some code and he said, this is what it looks like without Lambdas, this with Lambdas, and the Lambda one looked simpler to understand. I would like to encourage you to have a look at Peter Lorre's recent blog, where he talks about, or his presentation, where he talks about some of the idioms that he has developed for Java 8. And I tell you, a lot of them are very, very hard to actually read. Unfortunately, Lambdas are a bit like generics were when they first were released in 2004. As people start to use them, start to abuse them and overuse them in places where they really shouldn't be used. This idea with the Mixin has got application in other contexts too. I found one other application where I could add functionality to enums. I won't go into the details of that. But it's still going to take a little bit of time for Java 8 to really be used in a lot of production systems. Most of my customers are looking at it, but some are still stuck on 1.4. I've even got somebody who still has modules on 1.1. So hope none of you are in that unfortunate position. So that's it, and you're welcome to ask questions. No questions? Thank you very much, and enjoy the rest of the conference.